Good morning, friends. Today we are going to see that how we can do the estimation of hydrogen hydrochloride. That is our experiment number 10. So that we do with the help of non-aqueous titration. So previously we have seen the standardization and the preparation of perchloric acid solution. So we will use the same perchloric acid solution here for the assay of hydrogen hydrochloride. So first of all, the reference I have taken from the same book, Beckett Stanley, the page number 169 to 170, where it is given. It is given the in the heading the titration of the halides. Uh, in the case of non-aqueous titration, this is one of the important parameter how we titrate the salt having the halide with the help of non-aqueous titration. So here we have taken the example of ephedrine hydrochloride. So this ephedrine hydrochloride, when you will see its molecular weight, it is 2.201.7. This is a structure for ephedrine hydrochloride, and it is a salt of a weak base having a strong acid. So you can see here this it can be written in the form of RNS3 positive Cl negative. So ephedrine, we know it is a type of alkaloid, and generally these alkaloids are not soluble in water, but it is in the form of hydrochloride salt, though it is soluble in the water. But as we are using the non-aqueous titration, so we won't use water here for the during the titration. So here this will be directly titrated with perchloric acid. But the thing is that the HClO4 which we are using, it is also acid, and this is also acid. HCl. So this will not be titrated directly. So what we'll do here, in the case of hydrochloride, this is a basic principle of the theory behind this is that the all the bases which are having in the form existing in the form of hydrochloride salt, they are treated with the mercuric acetate. This is the mercuric acetate. They are going to form out the uh, mercurous chloride, and this is the acid. This Cl will got replaced by the acetate ion. So the we can say it will form the acetate salt, and this acetate salt is further reacted with the perchlorate, and this perchloric acid when react with the acetic acid, it will form the ClO4. This is the second reaction. This is the first reaction. This is the second reaction. Third reaction is that the ammonium salt of drug, acetate salt of drug, react with the acetic acid molecule. It will form the acetic acid molecule, and this amine got free. So this is also going to be, this is in the nutshell, when all these three reactions are added, they are going to give this final reaction. This is the reaction of the sample. This is ephedrine hydrochloride, mercuric acetate, which is used for the purpose to replace the halide, which is present in the salt of amine, and this is the perchlorate salt or the perchloric acid, which is used to titrate this drug. So finally, it will convert into ammonium ion and HCl and acetic acid and perchlorate. So this is the theory behind the non-aqueous titration during the titration of halides. Now we will see how we can prepare this ephedrine hydrochloride solution. So we know that in order to prepare one normal solution of ephedrine hydrochloride, we require 201 gram of ephedrine hydrochloride for a liter of solution. So we can see for zero point 0.1 normal, we have just divided it by 10. So for zero point 0.1 normal, it should be 20.17, and it is for a liter. But when we convert it for 100 ml, then automatically it will become 2.01. Now for zero point 0.1, 10 ml, it will be divided by 10. So it will be 0.2017 gram of ephedrine hydrochloride. Now for the 20 ml, it can be 0.4034 gram of ephedrine hydrochloride. So here what we'll do, here we prepare the solution by taking this solution. Now what you can do is just weigh out the ephedrine hydrochloride, that is the accurately weighing of ephedrine hydrochloride has to be done with the help of a analytical balance or the chemical balance. You will accurately weigh out ephedrine hydrochloride and transfer into conical flask having the 10 ml of mercuric acetate solution, which is prepared in the glacial acetic acid solution. Then we have to warm it and then allow to cool. Then we have to add the acetone so that it freely dissolve. Acetone is added so that it can be easily dissolved in that, and we will mix it Then finally we will titrate with the perchloric acid solution. This perchloric acid solution is nothing but the same solution which we have pre-standardized perchloric acid solution we have to take, that we have standardized in the experiment number 9. So this HClO4, when you will see its normality, which we have estimated already, we can see this normality was 0.1210. So we will assume the normality will remain same. 0.1210 will be the normality of this pre-standardized perchloric solution that will take in the burette. And in the conical flask, we are going to take the ephedrine hydrochloride as well as the mercuric acetate in this ephedrine hydrochloride with the acetone, and the indicator that we are going to take is a methyl orange. So here three things we are taking. We are drug, we are taking, that is the ephedrine hydrochloride we are taking in the conical flask, that is accurately weighed amount. Then we'll take the mercuric acid solution, mercuric acetate solution, that is 10 ml. 10 ml solution will take, that is prepared in the 5% glacial acetic solution. Then we'll add the 50 ml of acetone. Then we add the indicator, that is the methyl orange. Methyl orange will be taken as the indicator. Now we'll titrate this perchloric acid. We will add this perchloric acid solution in this solution until the color comes to red. When the color comes to red, we stop the titration. So this will give the endpoint. Now we have got the endpoint that we will record in our burette table, and the observation table will draw similarly as we have done in the previous experiments. So we will get the endpoint. Now afterward, what we'll do in the calculation? Just I will explain you the calculation part now. For the calculation, what you will do now, you have got one endpoint. Suppose the endpoint or the at the reading which has come out, suppose it is a 8.7 ml approximately. This if this is coming your endpoint, so whatever endpoint will come, you will put that reading. So we are supposing we are getting the endpoint at 8.7 ml. So what we'll do, we are having this factor that each ml of 0.1 N perchloric acid is equivalent to 0.00217 gram of ephedrine hydrochloride. So you can see here that for each ml it is written, isn't it? So that means for 8.7 ml you can calculate, and for the normality here it is written zero point 0.1. So here you can see it normality is 0.1210 that we have determined. So we can do the calculation for this is that for the normality of solution of perchloric acid, that is 0.1210 and 9.8.7 ml. So for 8.7 ml and the normality is 0.1210 normal perchloric acid solution, the amount of ephedrine hydrochloride will be how much? That is 8.7 multiplied by the 0.1210 divided by 0.1, that is the normality we have considered for this much, and this will be multiplied by 0.02017. So this much gram of ephedrine hydrochloride will be the resultant. So when you will solve it, it will come around 0.2123 gram. So this is the nothing but the amount that we have got on calculation. And suppose the weighing we have to do in this when you will prepare this solution of ephedrine hydrochloride in this, and the weighing you have to do. So in this approximately when you will weigh it accurately, suppose the weighing which you have done here is in place of 0.22, it is suppose it is 0.2150 gram. So this is nothing but the weight you have taken, and this is the weight which we have obtained. So percentage purity you can calculate. Percentage purity is nothing but the assay of the drug. So the calculated weight and the weight we have taken. The calculated weight we will put here, calculated weight of drug. Then we are writing here divided by, this will be divided by the amount of drug we have taken. Amount of drug, that is ephedrine chloride hydrochloride here. taken multiplied by 100. So calculated weight is here is 0.2123. 0.2123. And the weight we have taken, that will write from here. This amount will write, see here, here we have written here. It is 0.2150. That will multiply by 100. So this will come across 98.4%. So you can see here, like this we have to calculate for the ephedrine hydrochloride percentage. So this is all about the assay of ephedrine hydrochloride. Thank you.